Hello. In the previous video related to support reactions, we have seen the types of loads, types of beams, and types of supports. Here we'll see how we can take the moment of different types of loads and find the support reactions by solving some examples. The first example that we are going to solve is this one. Here we need to find the support reactions for this beam. 8 kilonewton per meter uniformly distributed load is acting. Then this 20 kilonewton point load is acting, and 15 kilonewton also it is a point load. In the previous video I have already taught you how we can find the total load when UDL is acting, but again we'll see. Like here we can see on this 3 meter span UDL is acting. It is 8 kilonewton per meter. This means that my total load will be equal to W into L. W, which is 8 kilonewton per meter, and my length is 3 meter, so it will be 8 into 3, which is 24 kilonewton. I can show this 24 kilonewton load as point load. This will act at the center of the span, which is ये जो 3 मीटर लेंथ है मेरी उसके सेंटर में ये मेरा 24 किलोन्यूटन का लोड लगने वाला है, which is I can say this much is 1.5 meter and this much is 1.5 meter. So center of 3 meter span में 24 kilonewton जितना लोड लगेगा. And if we talk about the moment that is acting due to this UDL, तो वो कितना हो जाएगा? अभी हमने उसे पॉइंट लोड में कन्वर्ट कर दिया है. एंड अबाउट ए वो कितनी मोमेंट अप्लाई करेगा? 24 इंटू 3/2, दैट इज़ 24 इंटू 1.5. देन अबाउट बी अगर मुझे ढूंढना है तो वो कितना हो जाएगा? मोमेंट विल बी इक्वल टू 24 इंटू परपेंडिकुलर डिस्टेंस विच इज़ 4 + 3 + 1.5, that is 8.5 meter, so it will be 24 into 8.5. Now let's just get back to this question. Here we need to find the support reactions, which I am denoting it using RA and RB. RA is the support reaction at A and RB is the support reaction at B. First of all, we'll take moment at A, and moment at A, so it is anticlockwise moment is equal to clockwise moment. We have already learned how we can find the moment of a force in the chapter coplanar non-concurrent forces. If you have not seen that video, then I suggest you to see that first. So here moment at A, that is we are taking anticlockwise moments is equal to clockwise moments. Let's see which are the anticlockwise moments. The first anticlockwise moment that we are having is RB will produce an anticlockwise moment at A. Then this UDL will also produce an anticlockwise moment at A. So we have two anticlockwise moments. One is because of RB and another one because of this UDL. It will be RB into perpendicular distance, which is 4 + 3, 7, plus we know that 8 into 3 we got the point load as 24. We can directly write 24, or you can write it as 8 into 3 into perpendicular distance, which is half of 3, so into 3/2, that is 1.5. Then we have the clockwise moment. Clockwise moment will be because of 20 kilonewton load and 15 kilonewton load, like this. It will be acting on A. If we see the distance, then it will be 20 into 4, and for 15 kilonewton load it will be 4 + 3 + 2, that is 9. So here we'll write equal to 20 into 4 plus 15 into 9. And then on solving this, we'll get RB into 7 plus 36 is equal to 80 plus 135. Therefore, RB into 7 is equal to 179 and RB will come as 25.57 kilonewton. Now we want to find the reaction at A. So reaction at A plus reaction at B is equal to total load. अभी यहाँ पे हम देख लेते हैं टोटल लोड कितना लग रहा है. तो टोटल लोड मेरा हो जाएगा 20 किलो न्यूटन प्लस 16 किलो न्यूटन प्लस ये जो लग रहा है 24 किलो न्यूटन. So we have 24 plus 20 plus 15 and we have already found RB. So RA is equal to 59 minus RB, which is 25.57. So we get RA is equal to 33.43 kilonewton. We have got both of our support reactions for this beam. Now this is the next question that we are going to solve. Here, as you can see, UDL is acting, then the moment is acting at C and the point load is acting at D. We'll show the support reactions. RA for the support reaction at A and RE support reaction at E. We'll take moment at A. Now here, as you can see, RE will produce anticlockwise moment. Perpendicular distance is 3 plus 2 plus 1 plus 2. That is RE into 8. Anticlockwise moment is equal to clockwise moment. Now this clockwise moment acting here is 5 kilonewton meter. So I'll just write it here. Don't make a mistake because this 5 kilonewton meter वो moment दी गई है. It is not a reaction. So you just need to write it like that. Then we have 15 kilonewton load. Perpendicular distance is 3 plus 2 plus 1, which is 6. So 15 into 6. And then we are having this 5 kilonewton per meter. So it will be 5 into 3 into half of the length, which is 3 by 2. That is 8 RE is equal to 117.5. And we get RE is equal to 14.68 kilonewton. Then RA plus RE is equal to total load. The total load acting here will be UDL का गिने तो it is 5 into 3 which is 15 kilonewton. Point load लग जाएगा center पे. Then this 5 kilonewton meter, that is moment, it won't be counted. So RA plus 14.68 is equal to 15 plus 15. So we get RA is equal to 15.32 kilonewton. Let's see the next question. Here we are having a point load 10 kilonewton. Then a moment is acting 25 kilonewton per meter. Anticlockwise moment. UDL of 5 kilonewton per meter. And UVL of 10 kilonewton per meter. Now first of all, we'll just convert these loads into point loads. Here this is already a point load 10 kilonewton. Then at D we are having a moment 25 kilonewton meter. Then this UDL will convert it to point load. Now here 5 kilonewton per meter UDL acting on 4 meter length, which means it will be W in 12 5 into 4. So this will be 20 kilonewton, which will be acting at the center of 4 meter. Then we are having UVL. Now let's see how we can convert this to point load. So for this, 10 kilonewton per meter load is acting on 3 meter span. So it will be 10 into 3 into 1 by 2. So for UVL, the total load acting is WL by 2. So it will be 15 kilonewton. वो कहाँ पे act होगा? Let's just see that. So it will act at 1 by 3 from B. यहाँ पे B बोल रहे हैं, मतलब राइट एंगल जो फॉर्म हो रहा है वहाँ से 1 by 3 मीटर पे वो एक्ट होता है. क्योंकि ये जो ट्राइंगल है उसका राइट एंगल जो फॉर्म हो रहा है वो बी पे हो रहा है, दैट इज़ वाई इट विल एक्ट at 1/3 from B. So 1/3 into 3 which is 1 meter, और बच गया जो वो 3 minus 1 which is 2 meter. Then we have this 20 kilonewton load which is acting at an angle of 30 degree with respect to the horizontal. तो उसे हम दो components में resolve करेंगे which is 20 cos 30 because it is adjacent to 30 degree. So 20 cos 30 will be my horizontal component and 20 sin 30 will be vertical component. This 20 cos 30 is equal to 17.32 kilonewton and 20 sin 30 is equal to 10 kilonewton. Now we have all the loads acting on this beam AB. Here we have support reaction at A which is VA and support reaction at B is VB. We'll take the moment at A, anticlockwise moment is equal to clockwise moment. VB will produce anticlockwise moment at A and perpendicular distance is 2 plus 2 plus 2 plus 2, that is 2 into 4 which is 8, VB into 8. Then we are having 25 kilonewton meter which is anticlockwise moment, so it will be plus 25. Then this 10 into 2, it will be clockwise moment. Then we have 20 into 6 because 2 plus 2 plus 2, that is 6. Then because of 15 kilonewton there will be a clockwise moment. 15 into the perpendicular distance will be 2 plus 2 plus 2 plus 2 plus this 1 meter will also come because it starts from here, so it will be 9 meter total. And then we have this 20 sin 30, that is 10 kilonewton load is acting, and the length of this beam is 11 meter, so it will be 10 into 11, or you can even write it as 20 sin 30 into 11. Then on solving this we'll get VB into 8 is equal to 360 and we get VB is equal to 45 kilonewton. Then VA plus VB is equal to total load, that is the total vertical load. Why I am using vertical word here? Because here we are having one horizontal load which is 20 cos 30. Now this total load will be 10 plus 20 plus 15 plus 10, that is it will be equal to 55 kilonewton. So we have VA is equal to 55 minus 45 which is equal to 10 kilonewton. And as we are having this horizontal load here, so we can write that our HA is equal to, here HA will be acting, and because of HA and VA there will be a resultant reaction. So HA is equal to 17.32, or you can say that HA minus 17.32 is equal to 0. So we get HA is equal to 17.32 kilonewton. Then we have RA, which we find using this equation. RA is equal to under root of HA square plus VA square, that is 10 square plus 17.32 square. We get it equal to 20 kilonewton. And then we'll also find tan theta. So we'll get tan theta is equal to VA upon HA. Here VA, which is 10 kilonewton, and HA is 17.32. Therefore we'll get tan theta is equal to 10 upon 17.32, which is equal to 0.577. And theta will be equal to 10 inverse of 0.577, which we get it as 30 degree. So here at the support A, we are having the reactions like this. Horizontal reaction, which is 17.32 kilonewton, then vertical reaction, which is 10 kilonewton, and the resultant reaction, which is 20 kilonewton, and the angle is 30 degree. Let's solve another example. Here, as you can see, 10 kilonewton loads are acting like this. Firstly, we'll just resolve this. 10 kilonewton जो लोड है वो पॉइंट सी पे लगेगा, एंड 10 इंटू 0.3 जितनी मोमेंट भी लगेगी सी पे. At A and B, we are having the reactions, which is VA and VB. पॉइंट C पे मेरा जो लोड है 10 किलोन्यूटन का वो लगेगा, और उसके साथ मोमेंट भी लगेगी, बिकॉज when the load is given like this, it will also produce a moment which will be equal to 10 into 0.3, 10 into perpendicular distance, which is 10 into 0.3, तो वो हो जाएगी 3 किलोन्यूटन मीटर. देन यहाँ पे डी पे मोमेंट भी लगेगी और लोड भी लगेगा. लोड हॉरिजॉन्टल डायरेक्शन में दिया हुआ है. मोमेंट कितनी हो जाएगी 10 इंटू परपेंडिकुलर डिस्टेंस, विच इज़ 10 इंटू 0.3, सो मोमेंट हो जाएगी 3 किलोन्यूटन मीटर एंटी क्लॉकवाइज डायरेक्शन में, और लोड जो लगेगा वो ऐसे लगेगा 10 किलोन्यूटन जितना. सो व्हेन लोड इज़ एक्टिंग लाइक दिस, तो लोड और मोमेंट दोनों ही लगेंगी, एंड कैसे लगेंगी वो हमने ऑलरेडी देख लिया है. अभी ए की बात करें तो बिकॉज हॉरिजॉन्टल लोड एक्ट हो रहा है, तो वहाँ पे एच ए वी ए और आर ए आ जाएगा. एच ए माइनस 10 इज इक्वल टू 0, क्योंकि 10 किलोन्यूटन जितना ही हॉरिजॉन्टल लोड लग रहा है. So HA will be 10 kilonewton. Then we have to find the moment at A. Anticlockwise moment is equal to clockwise moment. VB into perpendicular distance कितना हो जाएगा. D पे भी anticlockwise moment लग रही है. Perpendicular distance होगा मेरा 3 meter, because this total length is 3 meter. D पे लग रही है anticlockwise moment, which is 3 kilonewton meter. देन क्लॉकवाइज मोमेंट की बात करें तो 10 इंटू 1, देन दिस 3 किलो न्यूटन मीटर, वो है मेरी क्लॉकवाइज मोमेंट, सो प्लस 3. अभी बाकी रहता है हमारा 10 किलो न्यूटन का हॉरिजॉन्टल लोड. कमेंट करो, शुड आई ऐड इट और नॉट. सो वी डोंट हैव टू ऐड इट. वाई? बिकॉज it won't produce any moment about A. So we'll be having VB is equal to 10 by 3, that is 3.33 kilonewton, and then VA plus VB is equal to total vertical load. यहाँ पे total vertical load कितना हो जाएगा देख लेते हैं. The total vertical load will be equal to only 10 kilonewton, because सिर्फ वही है जो vertical load लग रहा है. So we have 10 is equal to VA plus VB. VB is 3.33. So VA will get it equal to 6.67 kilonewton. And then we'll find RA. We have already found HA. RA is equal to under root of HA square plus VA square, that is 10 square plus 6.67 square, which is equal to 12.02 kilonewton. And then 10 theta A will be equal to VA upon HA, that is 6.67 upon 10, which is 0.667. Theta will be equal to 10 inverse of 0.667, that is we get theta is equal to 33.70 degree. Let me just show the reactions acting at A. We are having horizontal reaction, which is 10 kilonewton, then vertical reaction, which is 6.67 kilonewton. Resultant reaction, we got it as 12.02 kilonewton, and theta is 33.70 degree. Here I have covered almost all the examples. We saw how we can take the moments of different types of loads and how we find the support reactions. Practice more and more questions so that you become powerful in this. And while practicing, if you have any doubt, then you can mail your question to me on my mail ID, or you can use the contact us page given on my website. Don't forget to like the video and subscribe my channel. Thank you.